Hello again, this is Miss Plata, Miss Silver Plata, and I am here to continue with Module 2, 6th grade math. Okay, I think we are in Lesson 3. Now make sure that you have your packets so that you can follow along with me. Lesson 3 in Module 2, we are going to interpret compute division of a fraction by a fraction. So we are dividing fraction by a fraction with more models. Okay, so beginning with here, draw a model to represent 12 divided by 3. Now there are two ways that you can do this. The first one we call partitive division, and let me show you how that works. Now remember, it says 12 divided by 3. So this tape represents the 12, and we are going to divide it by 3. Partitive means we need to partition 3 times. 1, 2, 3. So if that is 12, each of this part represents 4. Okay? So that's one way of modeling 12 divided by 3. What do we call it? Partitive division. Another way of modeling 12 divided by 3 is what we call measurement division. So again, the whole thing represents 12, and then it says measurement division, meaning to say each unit is 3. Okay, so here we go. This is 3. This is 3. So I need to continue until I get to the whole thing, which is 12. So this is 3, 6, 9, 12. Okay, so each unit is 3. So let me erase this part right here so that we can clearly see the difference between the two ways of expressing in a model what 12 divided by 3 looks like. Okay, so partitive division, you divide it by how many parts you have. Measurement division, each unit represents the measure of that part. Okay, so let's try an example for each of this model. Create a question or word problem that matches your model. So the first one is partitive division. Okay. Here's an example of that. 12 cards are shaded, or I'm sorry, 12 cards are shared with 3 people. How many cards does each person get? Now that makes sense. If that's partitive division, I have 12 cards shared with 3 people. So this part right here represents the 3 people. And then the question was, how many cards does each person? This person gets 4 cards. This person gets 4. And this person gets 4. So there's your 12 divided by 3. So this situation matches the partitive division. What about the other one? Measurement division. Here's an example for that one. 12 balls are put in groups of 3. How many groups are made? All right, so I have 12 balls, 3 in each group. So this is 3, this is 3, this is 3, this is 3. How many groups are made? So that's 1, 2, 3, 4. So that's the measurement division for 12 divided by 3. Pretty cool, huh? So, to continue, look at this expression. It says 8 divided by 2. So let's answer that. 8 divided by 2 is what? Of course, 4. Okay. Now, let's try a unit form. 8 ones divided by 2 ones. And what's the answer? 8 ones divided by 2 ones is 4. Okay? Let's use a different unit. Let's say this is tens. 8 tens divided by 2 tens. Yes, you're right. It's 4. Try another one. 8 thousands, okay, divided by 2 thousands. Yes, you're right. The answer is 4. Now let's say it's a fraction, but we're going to write it in unit form. Let's say 8 tenths divided by 2 tenths. What's the answer? Also 4. All right. Now, why do you think the quotient in these examples was 4? Why is it all 4? You are right. Because the units are the same. Okay? Ones, tens, thousands, tenths, etc., etc. Now remember, this lesson is all about dividing fraction by a fraction with the same denominator. So I think it's just appropriate to use this example so that we get the concept, okay? So fraction by fraction with the same denominator. Beginning with this example. It says write the expression in unit form and then draw a model to solve. Okay? 8 ninths divided by 2 ninths. So let's write that down in unit form. 8 ninths divided by 2 ninths. And then what does it say? Draw a model. Okay, so I'm going to get my 8 ninths. 1, 2, 3, 4, 5, 6, 7, 8 out of 9. So what does that mean? We are going to shade 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. So this is your 8 out of 9. 8 ninths. Then what does it say? Divide it by 2 ninths. So I'm going to take 2 ninths at a time. So this is 2 out of 9. This is also 2 out of 9. So just get 2 each time. All right. So how many groups of 2 ninths did we get? 1, 2, 3, 4. So going back to the expression, 8 ninths divided by 2 ninths. Let's say unit form, 8 ninths divided by 2 ninths is 4. All right? So that has been proven by a model. Okay? Now, let's try the next one. 9 twelfths divided by 3 twelfths. So write it as a unit form. 9 twelfths divided by 3 twelfths equals. All right, so using a Tate diagram, okay, the whole thing is 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many do we need? We need 9 twelfths. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this part that I just shaded represents 9 twelfths. Okay? So we are dividing it by 3/12. So what we're going to do, we're going to take 3 out of 12 at a time. So that's one group of 3/12. I'll get another 3. That's another group of 3/12. And another group of 3/12. So how many groups of 3/12 did we get? 1, 2, 3. So what does that mean? 9/12 divided by 3/12 equals 3. All right? So with that, I would like you to work on number 3. Okay? Or let me take this, grab it, and put it on the next page, because this is a little different. I don't want you to work on this on your own. Okay? Let's work on this together. I don't want you to get confused, because look at this one. How is this different from the first two? Yes, you're right. The numerators here, the 7 and the 3, they are common denominator, the same denominator. But the numerator, the 7 and the 3, actually, they are not compatible numbers. Okay? So if it's a normal division, 7 divided by 3, you actually get a remainder, don't you think? All right. So instead of writing the unit form, why don't we show a model so that we will see what happens to these fractions when divided. So I need 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need 7 ninths. Okay, 1, 2, 3, 4, 5, 6, 7. Now, always, always, always label when you are using a model. So that is 7 ninths. What do we want to do? We want to divide it by groups of 3 ninths. Okay. So I'm going to start with the first 3 ninths. So that's one group of 3 ninths. Okay. Here's another group of 3 ninths. Okay. And I need another 3 ninths, but I can't, because not all parts are shaded. What actually is shaded is 1 out of 3. Okay. I needed this 3 ninths to make it one group, but it's not all shaded. What is shaded is 1/3 of the group that I needed. Okay. So if I go back here, 7 ninths divided by 3 ninths, how many groups of 3 ninths do I see? And the last one is just part of the 3 ninths group that I needed. And what did I have here? Only one part out of the 3 that is supposed to be shaded is left there. And that's actually our remainder. Okay, there you go. So what does that mean? 7 ninths divided by 3 ninths is actually 2 and 1/3. Pretty cool, huh? Okay. All right. Continue. Exercise 1. How many fourths are in 3/4? How many fourths are in 3/4? So what's the division expression there? Division expression, 3/4 divided by 1/4. How many fourths are in 3/4? Okay, so in a number line, 0, so it's fourths. So let's say 1/4, 2/4, 3/4, and this is the whole thing, or 4/4. Okay, so it's asking you 3/4. From here to here is my 3/4. How many fourths are there? 1, 2, and 3. So 3/4 divided by 1/4 is actually 3. There are 3/4 and 3/4. Continue with exercises 2 to 6. So if you have your packet with you, there are several exercises that you can work on. Okay. For example, this one right here. 4/5 divided by 2/5. Okay. If you look at our very first example where we showed the same units, okay, the same denominator, what we are actually doing is just dividing the top number, right? Okay. So 4 divided by 2 is 2. Now, if you want to prove it, you can use a model. I got fifths and I need 1, 2, 3, 4. This represents your 4/5. You want to group it into 2/5 in each group. There's 2/5 and there's 2/5. So how many groups of 2/5 are there? 2. Okay. So without the model, what I actually did was just divide the top, right? Okay. Because remember, this lesson is dividing fraction by fraction with the same denominator. Okay. All right. What about this one? What do you think? Without the use of a model, they are common denominator. The denominator fourths. 9 and 3 are compatible numbers. So simply, yes, you are right. Divide 9 by 3. And of course, your answer is 3. Okay. And there are several more examples here. But I am looking at something like this. Okay. Common denominator, but 7 and 2 are not compatible numbers. So this is something that you will get a what? A remainder. Remember that? Okay. So let's use a model for this so that we can clearly see what's going on. I have 8s. I need 7 of them. 1, 2, 3, 4, 5, 6, 7, 8s. And what do I want to do? I want to get groups of 2 8s. So this is 2 8s. This is 2 8s. This is 2 8s. But this one is not both shaded. One is shaded, the other one is not. So what is that? That would be 1 out of 2. So we put this together. How many groups of 2 8s do we see? 1, 2, 3, and 1/2. So 7 8s divided by 2 8s is 3 and 1/2. Okay? So continue with those exercises on your own. You can pause the video, work on the problems, or you can go back to it later on and complete those exercises. Okay, number 5 is 13/10 divided by 2/10. Number 6 is 11/9 divided by 3/9. All right. So, in closing, okay, I have this for you. Imagine that your best friend missed today's lesson. What key ideas would you want your friends to know in order to be able to divide fractions by fractions with the same denominator? So what are you going to tell them? Yes, when dividing with like units, you can just divide the numerators and think of basic facts. Very good. For example, remember our examples? Let's say 8 centimeters divided by 2 centimeters. They have the same units, centimeters. So just use your basic facts. 8 divided by 2 is 4. All right? So again, you have your packet. You have a problem set that you can work on so that you can master this lesson. You also have an exit ticket that you can try. And I'll see you next time. Wash your hands. Stay safe. See you next time for more lessons from Module 2. Bye.